Okay, so I'm not sure if any of you have been in an interview and they ask you, have you ever done this? Have you ever worked with this skill? Do you know this? Do you know that? Or you've applied for a job and it said like, you must know this language or this thing or have taken these classes. Or if you're applying to grad school for economics, do you know real analysis, which is a branch of mathematics that we don't really use in too much. We a little bit in economics. And you say, well, yeah or no or whatever, depending on your experience. And you say, oh, but I could learn that if you said no. And say, no worries. It's just we asked that question just to see what your experience is, what you're used to. Almost like they're requiring you to know things that you're never going to apply. And this is actually fairly common. I've seen this a lot in interviews. And it like I said, it's something they ask for when you apply for economics grad school, even though it's not something you use too frequently. And the reason being is that they want to see how good you are at things that you're not going to use, because it's a signal for just your overall ability in general. But it's not necessarily exactly that you're going to be using it very frequently. And you can explain this in words, but this guy Michael Spence, developed a model that looks at using these kind of hoops and hurdles that you have to jump through as a means to determine how smart you are, as kind of like signal how smart you are, even if you're not actually going to be using any of the hoops and hurdles. So kind of like putting unnecessary requirements on a job description, even though you're never actually going to use them, just so that they're immediately weeding people out. It's really frustrating, honestly, but it's life. So I'm going to present you with this particular model. It's called the job signaling model, and I'm going to stylize it so that it describes people who get a master's degree versus not getting a master's degree. But just keep in mind this will probably be relevant to your current lives as you apply for jobs or you apply for colleges that are going to ask you to know things that you don't really need to know, just to separate you from your peers who might not know those things. But myself, I'm kind of an educational purist. I think you should learn things to learn them. I love learning. I hope I can kind of inspire you to love learning. But some people are just more practical and they just want to get the piece of paper that says, I've taken a hard economics course. So when people ask me, can I do math? I can say, look at this hard economics course. And that's fair too. I'm not here to judge. I just want you to learn these skills so that you can actually, learn about things like compounding and supply and opportunity cost and bring them into your daily lives, even if it's not in a useful business fashion. If it's not going to get you a job, it's still useful information. All right. So let's take a look at this model. Let's dive into it. And then I'm going to ask you the same comprehension questions. Remember, the structure of a model is more important than the solution concept. So I'm going to solve it, but I'm going to solve it in a very rudimentary way. This is a complex model. I can show you the underlying conditionalities if we left it in variable form, but it wouldn't be worth it. But I have it. I solved it yesterday again, just kind of refresh. This material is all kind of new. I added these slides I added them yesterday. So, I think that it's a cool thing that I kind of wanted to bring in, and try not to be too cynical about the value of your education, because to me it's more than a piece of paper, and I hope you can apply things that you've learned. Okay. Okay, so imagine there's a job recruiter, and that job recruiter has to hire someone for a very technical job. Let's say like a high-level computer programmer for like Google, or like an air traffic controller or something. Okay. There are two types of job seekers, so two types of applicants. You have gifted job seekers and normie job seekers. So gifted would be a little more clever, like a little smarter. Normies would just be your everyday average person. The recruiter cannot see which is which, so on the application, it's not going to say, "Oh, I'm clever. I'm a gifted person," but the recruiter can see if the job seeker has a master's degree or not. If the recruiter hires someone who's considered gifted, presumably the gifted person will excel in the career, then the recruiter gets a bonus for, let's say, the extra output from hiring a gifted employee. But let's say the recruiter brings in someone who kind of doesn't live up to the task. The recruiter is going to get a negative performance review, which will have some negative incentive for them, some negative W. So like a penalty if they hire a normie, a normal person for this technical job, and a bonus for hiring someone who's gifted. If the recruiter does not hire the gifted or the normie seeker, they get nothing. So hiring nobody gets you 0. They don't get penalized, but they also don't get a bonus. For gifted job seekers, it's less costly to get a master's degree. Okay, so it's easier for the gifted job seeker to get their master's degree. Let's say there's less time spent on studying. They can graduate in less time. They might get a scholarship for the master's. Their previous employer might have like compensated them for their master's degree. But for a normie, it's more expensive. So X is going to be greater than Y, X being the gifted job seeker's master's degree cost, Y being the normie job seeker's master's degree cost. Okay, sorry, X is going to be less than Y. So it's cheaper for the gifted person to go through master's program than it is for the normie to go through the master's program. Okay. Regardless of whether or not it's a gifted or a normie getting hired, they're both going to get the same salary, which we'll call Z if hired, and if they're not hired, they get nothing. Okay. So I'm going to break out the payouts. If the recruiter doesn't hire anybody, they get 0. If the recruiter hires a gifted person, they get the bonus V. And if they hire a normie, they get negative W. So best case scenario, the recruiter is going to try to hire the gifted person. Otherwise, they would hire nobody. And worst case scenario, they hire the normie. So these are the utilities, 0, V, and negative W, or the possible utilities. And we're ranking them. V is going to be greater than 0, which is going to be greater than negative W. So this is the best case scenario, gifted, no hires, number 2, normies, number 3. And remember, we're trying to just rank utilities, right? It doesn't matter what the value of V is relative to V plus 1, right? It just matters, is V greater than 0? Is 0 greater than negative W? Okay? Because that'll determine what the recruiter wants to do. Their incentive, basically. Okay, next up we have the gifted payouts. So if the gifted gets hired without a master's, they just get the salary, which is Z. If they get hired with the master's, they have to pay a cost to get the master's, so that's negative X, plus Z. So they get the salary, but they have to subtract out the cost of the master's, negative X. And if they get no hire without the master's, it's 0. So they don't get the salary, but they also don't pay for the master's, so that's 0. And then lastly, if they don't get hired, but they paid for a master's, they get negative X, which is the cost of the master's. So the best scenario for the gifted is you want to get hired without the master's. Then depending on if Z is greater than or equal to X. So if Z is greater than X, you want to get hired with the masters. If Z is less than X, then you want to get hired with not hired without the masters. And then the worst case scenario is that you get hired with or if you don't get hired with the masters, this last one. We're going to presume for the model that Z is going to be greater than X. Otherwise, the gifted will never want to get the masters because the salary will always be lower. Okay, and I'll show you that in the next slide. Okay, so the normie payouts, if they're hired without the masters, it's also Z, so they just get the salary. It's going to look a lot similar to the gifted's payouts, except the X is going to be replaced by Y, where X is less than Y. So the cost for the gifted to get the masters is lower than the cost for the normie. Okay, so all of the same things. If they get hired with the masters, they pay for the masters, negative Y, plus Z, the salary. If they don't get hired but they don't go for the masters, they get nothing. And if they don't get hired but they went for the masters, they pay the cost of the masters, negative Y. Okay? So for both the gifted and the normie, you're going to want hired without the masters first. And then depending on the strength of Z minus X and Z minus Y, that'll determine if this one is better than this and if this one is better than this. And then in both cases, these two getting hired, not getting hired, but paying for the masters is the worst. Okay. So I'm going to represent this one again using the extensive form. The extensive form for this one will look a little bit different than the extensive form for the price signaling model. And I'll show you how. So here we go. So if I have to move in a little bit. If this is the gifted student, okay, this is the normie student, or seeker, I should say. Okay. And JK, I don't want to do that yet. All right, so the dotted line means that the recruiter can't see if they're normie or gifted. So at this point, the recruiter can see no masters, or no masters, but they can't tell if it's no masters gifted or no masters normie. And at this point, the recruiter can see masters and masters, but not if they're gifted or normie. Okay. So basically, all the recruiter sees is does the seeker have a master's or not. The gifted student will know that they're gifted. The normie will know that they're normie, and they will make their decision accordingly. So the cost of education will be the only thing that really differentiates them. So the recruiter can't see if the student is, or the seeker is gifted or not. They just see if there is a master's degree or not. The gifted person and the normie know if they're gifted or normie, and so they know what their costs are, like the cost of going to the grad school or not. So the recruiter kind of has to make a decision. They can see gifted students, they can see students who have the master's, students who don't, and they can hire based on that, and that's really the only piece of information they have. So if you were a gifted student and you wanted to separate yourself from the pack, if you wanted to separate yourself from the pack, you might get your master's in order to look a little bit better. But if the cost of a master's is justifiable for the normie, they might also get their master's. In which case, the recruiter is going to see that both the gifted and normie job seekers are getting their master's. So the recruiter might hire everybody or hire nobody, depending on how prevalent gifteds are versus normies in the general population, if it justifies the bonus, basically. So like if 99% of people are gifted and the bonus is $100 and the the negative performance review is, let's say, the willingness to pay to not have that negative performance review is $1, then you would probably hire indiscriminately, right? But if the gifted ratio to normies is 1 to 100, then you might think twice about hiring indiscriminately. So if both the gifteds and the normies are getting their master's degree, it just depends on the overall population. If neither the gifted overall population and the size of the bonus relative to the performance review weighting, how you weight that monetarily. If neither the gifted nor the normie are getting master's degree, again, for the recruiter, they look the same, so they're going to hire based on the relative frequency of the gifteds versus the normies and how that weighs against the potential of getting a bonus versus getting a performance bad performance review. Okay, so it's in the best interest of the normie to look like the gifted, and it's in the best interest of the gifted to look different from the normie, depending on the size of the relative size of the cost. So if X and Y are very similar, what's going to happen is the recruiter is going to hire indiscriminately, because they won't really be able to tell who's getting their master's, or they're not going to be tell if the person getting their master's is gifted or not, if X and Y are very close. So if the recruiter is just hiring regardless, then the gifted's not going to get their master's, because why pay for a master's if they're going to be hired, and the normie's not going to get their master's. So what we're kind of looking for is a scenario in which the recruiter is going to hire someone with the master's and not hire someone without the master's. And really the only time that's going to happen is if the difference in cost for the gifted is much lower than the normie, and that the salary falls in between there somewhere, okay? Such that the gifted can justify getting their master's and the normie won't. And I'm going to break this all down in the next slide, but let's deconstruct the model as a whole. Okay, so given that the gifted gets their master's and gets hired, okay, so gifted gets their master's, this is their decision point, master's or no master's, and the recruiter's decision points are higher or no higher. So if the gifted gets their master's and gets hired, they're going to get the salary minus the cost of the master's, and the recruiter is going to get V for hiring a gifted employee. If the gifted gets their master's but doesn't get hired, they lose the cost of the master's, negative X, and the recruiter gets nothing for not hiring anybody. Okay. The gifted doesn't get their master's but gets hired. That's kind of like the best case scenario for both of them. The recruiter gets V for the bonus, and the gifted gets Z, the salary. But the gifted does not pay for the master's. If the gifted doesn't get the master's, doesn't get the salary, doesn't get hired, then it's 0, 0. And then everything here is going to look exactly the same, except X is going to be Y. So if the normie gets the master's and hired, it's going to be Z minus Y. The recruiter is going to get the negative performance review for negative W. If the normie gets the master's, doesn't get hired, they're going to pay the cost of the master's, negative Y. And the normie is going to, the recruiter is not going to get anything for not having hired anybody. If the normie doesn't get the master's but gets hired, that's his best case scenario, or their best case scenario. I need to stop using gendered pronouns, I apologize. If the recruiter doesn't get the master's and does get hired, that's their best case scenario. They're going to get Z, the salary, but the recruiter is going to get negative W for hiring a normie. And then lastly, if the normie doesn't get the master's and doesn't get hired, it's going to be 0, 0. Okay. So this dotted line just means that the recruiter can't see if the job seeker is normie or gifted. Okay. Who are the agents in this model? So you have the job seekers is one, which with some probability can be either gifted or normie. And then the recruiter is number 2. So 2 agents, the seekers and the recruiters. Or if there are multiple seekers and multiple recruiters, many agents. But those are the 2 styles of agents, seekers and recruiters. Let's say the 2 classes if you're into like MMORPGs or something like that. Okay, what are their objectives? So the job seekers want to maximize their future profits subject to having paid a master's degree or not. So they're looking for maximizing their salary and minimizing the cost of a master's degree, essentially, if they even need to get it. So if I were gifted, I want to maximize Z minus X, or Z, or 0, or negative X. So pick the highest of those. And if I were normie, pick the highest of Z minus Y, Z, negative Y, and 0. Okay. The recruiter wants to, their objective is to get the highest bonus, basically, or the highest monetary incentive. So it's either going to be getting a V, which is the bonus, getting nothing, or getting the negative W, the negative performance review. So the seekers are trying to maximize their payout and minimize their cost, and the recruiters are trying to maximize their payout, which we could boil it down to maximizing their bonus and minimizing their negative performance review. And remember, at each one of these little payouts here are their utilities. And the way it's standardly written, I guess I kind of glossed over this, is that it's usually the first Z minus X will be the first mover. So the gifted moves first, the seeker moves first, they decide to get the masters or no masters. And then the second one will be the recruiter. Okay, so the second mover. And that's just kind of practice. It's like how it's usually written. You know, I don't expect you to memorize where the payouts go relative to each other. So if I put this on a test, I'll write left hand is gifted, or left hand is seeker, right hand is recruiter. What can incentivize a gifted seeker to get a master's degree and a normie to not? Okay, so think about this. If you wanted only the gifted seeker to get the master's degree and you wanted the normie to only not get the master's degree, what would you do? So you would place the salary in between the cost of getting a master's degree for a gifted person and the cost of getting a master's degree for a normie, right? Because let's say the normie pays $60,000 for a master's degree, and that includes just like extra effort or whatever. I'm just monetizing it for the sake of putting a number on it, but extra effort, the opportunity cost of their time, no scholarship or whatever. If it costs the normie $60,000 to get a master's degree, and the gifted student can do the same thing in $40,000, if the salary is $50,000, the normie is going to say, no, I don't want the master's degree, it's too expensive. I'd rather not get hired. And because if I get hired, it's going to be negative $10,000 that I see, basically. But if I don't get hired, I get nothing. So 0 is greater than negative $10,000. Right, so if the normie costs $60,000, salaries $50,000, gifted costs $40,000. The gifted will get the master's degree because $50,000 is more than $40,000. The salary is higher than the cost. So this is what we call like a separating equilibrium, an equilibrium in which don't worry about separating equilibrium. Sorry, you don't need to know it. But at any rate, the job seeker would want to put the salary such that the recruiter would want to put the salary such that it falls in between the costs of the master's degree for the two people. So Y being the cost of the master's degree for the gifted should be the highest, or for the normie should be the highest, then the salary, then the cost for the gifted. Okay. What is the seeker's maximum willingness to pay for a master's degree if they know they will get hired? Okay. So it's going to be Z, their salary, right? If I have a salary of $50,000 and I make $49,000, and it costs me $49,999.99, then it's better to get the job and get the master's than it is to not get the job, not get the master's. Okay? Because 1 cent is better than no cents. Okay? What is a seeker's maximum willingness to pay if they know they won't get hired? Okay, so if you know you're not going to get hired, you're not going to get the salary. So you're just paying out of pocket, right? So you're going to not want to pay anything, zero. Hopefully this makes sense. Okay? So the maximum willingness to pay for the master's, if you know you'll get hired, is the salary, or let's say 1 cent under the salary. If we're being like completely discreet, and being indifferent doesn't count, but it should be really the salary. And if they know they're not going to get hired, it's going to be zero, because you don't want to pay out of pocket for something that's not going to benefit you. If a seeker knows they will get hired if they get the master's degree, and that they won't if they don't, what is the opportunity cost of a master's degree? So you know you're going to get hired if you get the master's degree. Okay, so you get Z minus X, and, or Z minus Y, either or, depending on if you're gifted or normie. So that's your utility if you get the master's degree, either Z minus X or Z minus Y. And if you know that you won't get hired if you don't get the master's degree, so you're going to get zero, what's the opportunity cost of a master's degree? Zero. Right, so if you get the master's degree knowing that you'll get hired, that's the better of the two options. If you know you won't get hired, your next best option is to not get the master's degree. So you get zero, okay, and to not get hired. I kind of want to rephrase that because I don't think I did that to the best of my ability. Okay, so let's say you're a job seeker. You know you're going to get hired if you get the master's, and that you won't if you don't. So you do end up getting the master's. That's the choice that you make. What's the choice that you don't make? The choice that you don't make is not getting hired, not getting the master's degree. Okay, so you'll be in this little territory here, 0, 0, or 0, 0. So the utility you get from the choice you didn't make is 0, right? So that's your opportunity cost. Okay. So, all right, so now that you're a little bit more familiar with the model, I just want to go on a brief tangent about why being quantitative and having quantitative logic kind of benefits this model versus just describing it in words. Because when I was describing it to you guys maybe like a slide or so back, and I was saying the recruiter will hire indiscriminately if the relative population of gifteds to normies is high enough and the bonus is high enough relative to the bad performance review. You know, that's kind of shaky grounds that we're talking about, right? Like what does it mean to be relatively high and relatively low? When I put in actual mathematical representations, I can represent them, the conditions for the recruiter's exact weighting and like when they'll hire all the time, when they'll hire none of the time, if they only see master's degrees, and if they only see no master's degree, and then I can assign what the gifted and the normie will do in response to that. So I have a very concrete best response for both the recruiter and for the gifted and normie type job seeker. If I just describe it in words, it's not very concrete. It's pretty abstract. It's hard to pin down exactly what I mean, but I can show you the equations, and they're going to be meaningless, but because it would take longer to explain the equation than it would be worth it for the purpose of this class. But basically, like, the revealed probability is going to be different if the recruiter sees the master's degree versus not seeing the master's degree. So I'm going to put some conditionalities on the size of Z, the size of W, the size of Y, and then we'll like kind of qualitatively, logically explain the model. So this is all going back to the economist toolbox, right? So we have abstractions that get us to this point where we have a model, right, with a limited choice perspective, but still kind of saying something unique and relevant to the world. It explains a problem that I see fairly frequently if you're like interviewing or applying for jobs, or going to grad school, or just trying to show that you're competent, basically. It's because sometimes you'll have to overcompensate relative to what's actually necessary just to separate yourself from the pack. And that's exactly what this is. And I said packed again, pack. That's exactly what this is. You're signaling that you're a gifted person, or for the normie, you can't make that signal. In order to, so once the signal happens, so that the respondent to the signal will know that you're a gifted person, and then hire you or behave accordingly depending on what you're looking at. Okay. So it's logic in the sense of, once we have the framework, everything's pinned down. Assuming rationality and assuming that everybody knows the rules of the game, the equilibrium will follow suit, right? There's no way to get a different equilibrium unless you change what equilibrium means, right? But this is really the only possible solution that you'd get, once you put on conditions on Z versus W versus X. Z versus X versus Y, excuse me. So given certain Z's, certain X's, and certain Y's, there's only one solution. Given certain Z's versus X's versus Y's, there's only one solution. And it might be the solution is two equilibria, but there's only one way that a scientist can get there. Like, there's only one mathematical possibility. Okay, so we're using logic, we're using a graphical analysis. It's not like a graph in the sense of like you're graphing a function, but it's a graphical analysis. It's using a form to kind of simplify things. In this case, the extensive form. It's obviously mathematical in the sense of that you're applying numbers, and even though the numbers here will be kind of similar or kind of simple, it'll be the real model is really math. It's given a certain condition, derive the best response function, and then which is mathematical, and then use that to categorize an equilibrium. So it all kind of interplays: the graphical analysis, the logic, the mathematics, and the model, and the abstraction, which gets us to this state of the world, right? So you can't build this without the abstraction. Otherwise, you're just describing the real world, and it's complex. Oh, what just happened? Come back. Extensive form, come back. Okay. Did I already do this? Yep, I already did this, so I guess I went back a slide. Sorry. Okay. I already did this one too. All right. So if y is greater than x and x is greater than z, right? So if the cost of getting a master's degree for the normie is higher than the cost of getting a master's degree for the gifted, which is a key function of the model, we can't switch that. So y is always going to be greater than x. But if x is greater than z, if the cost of getting a master's degree is greater than the salary, so the cost of the master's degree is greater than the salary for the normie, but it's also greater for the gifted. So if the salary is less than the master's degree, then why would you get the master's degree? Nobody gets it under this condition. So if nobody's getting the master's degree, what's going to happen? The recruiter is only going to see people without master's degrees, so then they have to make their decision with no real other information besides how prevalent gifteds are in the world versus how prevalent normies are in the world, and weigh that against the difference between the bonus and the cost of the negative performance review. So if the negative performance review is really high and the number of normies is relatively high, then you're going to probably not hire anybody. But if the cost of a negative performance review is pretty low and the number of normies is pretty low, then you probably will hire everybody, because you're either going to have to hire everybody or nobody, because they're all going to look the same to you. You can't tell because they're all going to have no master's degree. Okay, so if no one goes to school, then the recruiter won't be able to distinguish between job seekers. If there are enough gifted seekers in the overall population to justify sometimes taking a bad performance review, they will hire everyone because they can't tell. If there's not enough gifted job seekers and the bad performance review is relatively high, then they'll hire no one. Okay. What happens if the salary is greater for both the normie's cost and the gifted's cost? Okay. So the salary is more than the cost of education for both. So if the gifted seekers go to school, then the normies will too, because they want to get hired too, meaning recruiters will again not be able to tell the difference and will either hire everyone or no one. So it devolves back into the last problem. Okay, so in this case, let's say the gifteds decide to go to school. The normies will also want to have the same signal, so they're going to go to school because z minus y is greater than 0, so they have every incentive to get hired. So they want to look like the people who are getting hired. If that's the case, what ends up happening is the gifteds will stop going to school, which means the normies will also stop going to school, and then there will be no master's degree, and we're going to go back to the same scenario as before. So the recruiter is going to say, we're going to hire regardless of whether or not you have your master's. You know, as long as the gifteds are getting their master's degree, the normies will want to do that too, because z minus y is always going to be greater than 0, right? So if the gifteds are getting hired and the normies aren't, the normies are going to want to look like the gifteds. If the gifteds know that the normies are also getting their master's degree, you're considering z minus x versus z and negative x versus 0. So the gifteds would rather not have to pay for their master's degree if it gives them no additional benefit, if they don't look different from the normies. So that they can't really signal that they're gifted. So there's no real difference to them if they're getting their master's degree or not, except for they're paying for a master's degree. So in this case, the benefit of getting a master's degree has nothing to do with the amount of education you're getting. It's not, oh, I've taken, finance courses, so I'm better at finance, and that'll help me with my job in the long run. No, I've taken finance courses so that I look better at finance, so that people who haven't taken finance courses won't get hired. It's a cynical view of the world, but it's probably a more accurate view of the world based on 29 years of lived experience. this is how it typically goes. But that's the case. So there's no benefit for the gifted getting the master's degree, except in as much as it makes them look different from the normies. So they're not going to get the master's degree unless the normies aren't getting their master's degree. And the only case that will be is if the salary falls in between the gifted's cost and the normies' cost. So if the normies' cost is greater than the salary, the normies won't get their master's. And if the gifted's cost is less than the salary, then the gifteds will get their master's. So if the gifteds are the only ones getting their master's, that provides some information, a signal to the recruiter, who then sees, oh, look, there's no way that the normies are ever going to get their master's, because why would they do that? That would only hurt them, because if Z is less than Y, then they're getting a negative payout here and a negative payout here, so they're never going to get their master's degree. They're only going to not get their master's degree and, pray for the best that they get hired, but they won't. So they're not going to get their master's degree because it's too expensive relative to the salary. They can't justify it. So if I'm a recruiter and I know that no normie is getting their master's degree, I'm only going to want to hire people who get their master's degree, because only the gifteds will get their master's degree, because Z minus X is greater than Z. Z minus X is not greater than Z. Z minus X is greater than 0, right? So if the gifted knows that they're going to get hired if they get their master's degree, and they know that they won't get hired if they don't, they're always going to want to get their master's degree, because the salary is greater than the cost of getting the master's degree. Z minus X is greater than 0, right? So if the choice is getting hired and getting your master's degree, so putting in a costly signal in order to get hired, you'll do that because the salary justifies it, because Z minus X is greater than 0. Z is greater than X, the salary is higher than the cost of getting the master's degree, and you know that if the recruiter sees that you have a master's degree, you'll get hired, then you'll get the master's degree, okay? But this all hinges on the fact that you have to be able to provide a signal. You as a gifted person have to be able to provide a signal that you're gifted that the normie cannot replicate. If the normie is getting your master's degree and you're getting a master's degree, then the master's provides you no additional benefit. You're not sure if you're going to get hired or not. It depends on the underlying function for only the recruiter and has nothing to do with whether you're gifted or not, okay? But if you can provide a signal that you're gifted, you'll do so in order to get hired, okay? So the whole model hinges on the fact that, if Z falls in between, then there's going to be a differentiating factor between the gifteds and the normies, i.e. they're going to get a master's degree that the recruiter can see, and the recruiter will make their decision solely on the fact of whether or not there's a master's degree. So it's essentially getting rid of this dotted line. Okay, so if there's this costly signal that the gifted can do, but the normie cannot, right? If the gifted can be the only ones getting their master's degree, it provides 100% accuracy on whether or not people with their master's degree are gifted, and 100% accuracy on whether or not people without their master's degree are normies. Okay, so it removes all probability for the recruiter. They don't have to guess whether or not the person with their master's is normie or gifted. They just know that they're gifted because the normie can never replicate that. Okay, and then a gifted would never not get their master's degree. They would always get their master's degree if they know that normies can't get their master's degree, because Z minus X is going to be greater than 0. Okay, but in the first two scenarios, if Z is below both costs or Z is above both costs, then the normies and the gifteds are going to want to act the same way. They're both going to eventually devolve to not getting their master's degree, because there's no signal that getting a master's degree provides. Okay, because the normies could always replicate acting like a gifted. Okay, so that's really the heart of the model. And I'm going to put some actual numerical values on it so you can see exactly what I'm talking about. Okay, so I've thrown on some numbers here. Okay, so let's say that X, the cost of school for the gifted is 1. The cost of school for the normie is 2. So the normie has to pay more for the master's degree. The salary is 1.5. So this is the case where the salary falls in between their two costs. So you should expect the gifteds to get the master's and the normies to not get the master's. The value of the performance review is 2, or sorry, the value of the bonus is 2, and the value of performance review is -1 if they hire a normie. Also assume that 4/5 of people are normies and 1/5 of people are gifted. Okay. So here we go. Here are the actual utilities. So if the gifted gets their master's, they pay 1, but the salary is 1.5, so they get 1 minus 1.5 or 0.5. Okay. And then if the recruiter hires them, they get 2. If they pay the cost for the master's but don't get hired, it's -1, 0. If they don't pay for the master's and they get hired, they get the salary 1.5 and the recruiter gets 2. And if they don't pay the cost, they don't get hired, so they get 0. And the recruiter gets nothing for not hiring anybody. And then if the normie pays the cost of a master's 2, they get a salary 1.5. 1.5 minus 2 is -0.5. So that's their benefit here, their utility here. And -1 is the cost of a negative performance review for the recruiter. Okay, if the normie gets their master's but doesn't get hired, they just pay for the cost of the master's, -2. If they get hired without the master's, they get the salary 1.5, and the recruiter gets the negative performance review of -1. And if nothing happens, they get 0. Okay. Sorry. So let's say you're a normie. What do you want to do? Do you want to get -0.5 and -2, or do you want to get 1.5 and 0? So if you get the master's degree, how would you rank these? Sorry. How would you rank these 4 outcomes? How would you rank their 4 utilities? So best case scenario, they don't get the master's degree and they get hired. Second best case scenario, they don't get the master's degree, they don't get hired. Third best case scenario, they get hired, but they get the master's degree, so they get a loss. And then the worst case scenario, they don't get hired. So in any case, it's better for them to not get the master's degree. There's no scenario where they would want to get a master's degree, because not getting the master's degree is better than getting the master's degree and operating at a loss. So every normie won't get their master's degree. Okay, what about if you're gifted? Okay, so if you're gifted, how would you rank these options? Best case scenario, you get hired without having to pay for a master's degree, 1.5. Next best case scenario, you're hired, but you pay for the master's degree, 0.5. Third best case, you're not hired, nothing happens, you get 0. Fourth case scenario, you're not hired, but you've already paid for the master's, -1. So 1, 2, 3, 4. So there's a scenario in which you will get your master's degree, and that is if you know getting a master's degree will get you hired, or you think probabilistically that getting a master's degree will get you hired, then you'll get the master's degree. But otherwise, you'd rather not get the master's degree. Okay, because it's 1, 2, 3, 4. So if you know you're not getting hired, you're definitely not going to get the master's degree. But if you know that getting the master's degree will get you hired, you're definitely going to get the master's degree, because getting hired is better than not getting hired. Okay. Okay. So if you're a normie, you would rather not get the master's degree because it's too expensive. Even if you get hired with the master's degree, it would cost more than getting hired without the master's degree. If you're gifted, you would still prefer to not get the master's unless getting the master's was the difference between getting hired or not. Okay. Getting hired with the master's degree gets you 0.5. Not hired without the master's degree gets you 0. So 0.5 is greater than 0, so you'd rather be here than here. Okay. So if you could do something to get from here to here, you would do it, basically. So if getting your master's degree gets you hired, you would take it. If you're a recruiter and you think that neither normies nor gifteds are getting the master's degree, you won't take your chances. Okay, so 20% of people are gifted, 80% of people are normies. excuse me, if you are a recruiter and you have a 20% chance of getting a bonus of 2, okay, your expected utility is going to be 0.4, 2 times 20%, okay? And if you have an 80% chance of getting -1, the negative performance review, your expected value for hiring a bad person is -0.8. So if you add these two up, 0.4 plus -0.8, you're at -0.4, right? So that if you just hire indiscriminately, if you hire if both normies and gifteds are getting their master's degree, then you're not going to hire, because in all likelihood you're going to see a loss. You're going to see -0.4. Okay? If both of them aren't getting their master's degree, same thing. You can't differentiate if they're normie or gifted, so you just kind of have to go with the relative weighting of how frequently they appear in the population and your chances of getting the bonus or not. Okay, so the negative performance review times the probability of getting that negative performance review is higher in absolute terms than the positive bonus times the probability of getting that positive bonus. So, you're more likely to lose if you hire someone and you can't tell if they're normie or not. Okay, so if everybody's getting the same thing, if both job seekers are getting their masters or not getting their masters, the recruiter is going to choose to not hire. Okay, and kind of what I was saying before, if we play around with these numbers, if we make the percentage of normies, percentage of gifted in the population higher, and we make the bonus higher, then the value will change, but it will change like that. So, the second that this becomes greater than 0, the probability of getting, so the second that 2 times the probability of getting a gifted plus -1 times the probability of getting a normie becomes greater than 0, then you would rather hire indiscriminately, because then you'll be greater than 0, which is the utility you get from not hiring. So you're either hiring everybody or hiring no one, depending on how high this is, how high this is, how low this is, and how high this is. Okay. Okay, so the stable outcome is that gifteds will go to school, the recruiters will hire them, and normies will not go to school or get hired, right? Because we said that there's no scenario in which a normie will want to get a master's. There's one scenario in which a seeker will get their master's, and that is the gifted seeker will only want to get their master's if it means the difference between getting a job and not getting a job. Okay, and the recruiter will only hire people with a master's if they know that they're gifted, right? So if the normie can't get a master's, then 100% of the people who are getting masters are going to be gifteds. And if I'm a recruiter and I know that 100% of the people who are getting a master's are gifteds, then I don't have to weigh this probability anymore. I know that the probability is going to be 2 times 100, okay? That we're going to be here and not here, okay? So 100% of gifted students will get their master's. 100% of recruiters will hire people with their so the recruiters will hire 100% of people with their masters and 0% of people without their masters. And 0% of normies will get their masters. That is your stable outcome. Okay? So this is all to say your education is completely meaningless in any real regard, except that it's a signal that you are smarter than someone who didn't get an education. It's all about the gifted student didn't become gifted as a result of getting their master's. They became gifted before they got the master's, and they got their master's to prove it. Of course, I'm joking a little bit, but there's a little bit of truth to it, probably. Okay, so that concludes the 3 different models. Next up, I'm going to do a recap. So, stay tuned. So there's probably one more video left.